So for almost a decade, Android developers have been using XMLs for building UIs. While XML has been a reliable way of creating UIs in Android for many years, it can be cumbersome and time-consuming to write and maintain. With the introduction of Jetpack Compose, developers can now create UIs directly in code with Kotlin, using a modern and declarative way of creating UIs in Android. Welcome to the Jetpack Compose crash course. So in this course, you'll learn how to create beautiful and dynamic user interfaces for Android apps using Jetpack Compose. We'll start from the very fundamentals of Jetpack Compose and gradually move toward designing complex UIs. We'll cover the basics and fundamental concepts behind Compose, such as the declarative paradigm shift, the dynamic concept, content, recomposition, and more. So without any further ado, let's get started. So if you're new to Android or Jetpack Compose completely, let's start with this simple question. So what is Jetpack Compose? So Jetpack Compose is a new UI toolkit built for designing user interfaces for Android. So it's based on a declarative approach rather than an imperative approach which we used before with XML, which means you describe what you want to see based on a state. So for example, if the state changes for a card, then it's going to be in an expanded state, then we can show a full content. And if not, then we are going to show a collapsed view. So we are going to get into states more later. So let's go to another question and ask ourselves, so how does Composable know how and when to update the UIs? So we have already answered the first question from the definition of Jetpack Compose. So well, the Compose framework uses a reactive streams or a state to know which part of the composable has changed and update the part affected accordingly, which makes it more efficient and when dealing with complex UIs. So let's look at a simple composable functions and understand how it actually works. When you create a brand new Compose project in Android Studio, you're going to get the code like this one. But if this is just the first time you are opening up Compose, you're going to get lost. So for this case, I'm just going to delete everything and then we can understand when we progress through. So I'm just going to delete all of this here and actually understand what we are writing here and what we are getting from Android Studio whenever we create our project. Okay, so previously when we wrote XML code, we usually used here not the set content. We used the set content view. So we used this set content view here and passed the layout raise ID here in order to initialize it here. And basically with Composable now we are going to use a lambda function. So when you see these two curly braces here, you understand that this is just going to be a lambda function. And this basically is where we are going to call our Composable so that they can be rendered. And you might be asking yourself, what is a composable function? So a composable function is just a function that is responsible for rendering a specific part of your app's user interface. So it's just a normal Kotlin function that is annotated with @composable. So for example, here we can create a composable. Okay, so to create a composable function, you can easily just create a normal Kotlin function. So for example, here I'm going to create this function. It's going to be called Hakuna Matata. And basically here we can pass in parameters as how we create a normal Kotlin function. So for example, here we can pass a parameter that is called name, and this is just going to be of type a string. Okay, so composable functions by default, they are going to return a unit because they are not returning anything, but they are rendering a UI part. So for this case, we have to tell Composable framework that, hey, we want this function here to be a composable. And for this case, we have to add here the composable annotation. And now you can see here, this is going to be marked as a composable. And you can see when we want to differentiate between composables and normal functions, by default, normal functions, we are going to start here with a small letter, but here I'm going to start with capital letter. So with this case, I know that, hey, this is just a composable functions whenever I call it inside our activity or different places. So for that case here, we can pass in a name. For example, if we want to render a text, we can easily create a text composable, which is just a built-in text composable. And here you have to pass in several parameters. So one of the parameter is just the text, and this is just going to be a string. So for example, here I'm going to use a string template and access the name. Then right here, Hakuna Matata. Now, in order to render this, we have to call it inside our set content. So for this case here, I can just call here Hakuna Matata and basically pass in the name here. So for example, I can pass any name here. So I'm going to pass in Hood Lab. Okay, so we have invoked here our composable inside our set content. But in order to view this, we have to run it inside our application or inside our phone or our emulator in order to view the changes which we have made. But the composable has an alternative to the editor which we had with the XML. So we have to create the preview composable. So in order to create a preview composable, it's just normal as how we create here the function. So we can annotate here with @preview and also annotate this with @composable. Then create here a normal function and call this preview. So now we can directly call here our composable and preview what we are changing. So now you can see here there are icons which are appearing here. And basically if you want to preview it directly to your phone, you can just click this one here. But for our case, we are just going to go to our editor here. And now it's going to initialize here and see our preview directly inside Android Studio. So now here we have our text written here. As you can see, now we passed in here the name Hood Lab, and you can see Hakuna Matata is also going to be rendered here. But you can see the contrast is not really good because we're using black text in a black editor here. So for this case, we can just customize our preview to show different type of background. So for example, here we can say the background and make this to be true. So right now here you can see our background is changing back to white, and because we have added this parameter here. So there are different parameters which you can pass inside the preview composables, but for now let's stick with this show background here. So each composable has a set of properties that we can use to modify and add behavior to the composable. So for example, here we have a text composable, and let's collapse this. So we have seen one properties which we have changed here, which is just the text. And there are other properties which we can use to style or change the properties here. So when you press Ctrl Q to our text here, you can see that this is going to fetch up the documentation. And you can see all of these are the properties which we can use to change our composable. And when we used XML, we used these properties and changed, for example, the font weight and other thing. So for example, here, let's change our font weight. Now here we can pass in to be a bold font weight. So you can see font weight.bold. And now let's preview again here. Text is now bold. And this is just really simple. You just directly pass it here. Okay, so another property which we can try to change here is our composable's color. So let's just collapse this and pass in here the color. And we want, for example, this to be red. So we can just use here our color. And let's search for red. And now directly here we are going to change our color. Now let's just go again to our preview and reload again. We have changed here our color to red. So for example, here we can change the text size. So we can just pass in here a property for changing our text size. And this is just going to be font size here. So we can pass in here our font size, for example, to be 20 SP. Text has already changed the size, so there are more properties which you can use and experiment to them so that you can just get familiar with the properties which you have. And each composable has different properties which you can use to customize your composable and add different behaviors to your composable. So one special property we will highlight here in our course is the modifier. So this you're going to see it a lot, and let's pass in here a simple property and call this modifier here. So what is a modifier? So a modifier is just the property that is used to apply visual and behavioral changes to a composables. So we can add different types of visual and transformation inside our composable by using a modifier. So for example, here we can pass in a modifier. Let's pass in here, which is just androidx.compose.ui. And this modifier here, we can pass in, for example, padding. Now let's just pass all here padding. And this is just the layout modifiers, and we have several types of these modifiers. Let's give it a 20 dp padding. You can see here our text has now a padding. So we have applied the padding here and also here, which is just 20 dp. So these are just easy to modify your composables directly. So you can pass this dynamically. So for example, with an condition, then you can just change this padding. We have been dealing with the text composables only. So I want to highlight you to other composable, like when we want to show an image and also apply other modifiers to these particular composables. Now for this case, let's go to our resource manager here, and you can import here a new drawable by clicking this import drawables. Now you can just navigate to a place where you have an image, or you can just download the image on the internet. So for example, for my case, I'm just going to use this Hakuna Matata image from the Lion King. So for this case, let's just click next and click import. Now inside here we have our image that is named Hakuna Matata. Now let's see how we can also add other composables inside our code. Okay, now let's add here below a different composable. And you can just use here comp as a shortcut to create your composable. Now let's just call this Hakuna. Now directly inside here we can just call an image composable. So now we have an image, and this has different sets of properties which you can also pass. So with the text, we passed in properties that can be used to customize the properties. Now with the image here, we can pass in here, for example, a painter resource, which is just going to directly look for the resource ID. So for our case here, let's just first. So we can pass in here the named argument property. Then let's pass in here our painter resource. Now we can just go to ara.drawable. The next case here, we can pass in here the content description, and this is just for accessibility purposes. So you can tell, hey, this is just an image. So for example, here we can just call this Hakuna Matata image, or you can just directly pass in here null. So this is when people with disabilities want to use your application, then they can know, okay, so what this represents here. Also, we have other properties which we can pass in here. So for example, now let's just preview here also our Hakuna Matata image here. Now similarly, we can just copy this, press Ctrl C and press Ctrl V. Now instead here of previewing Hakuna Matata, now we can just call this Hakuna Matata image. And directly here, let's call our Hakuna Matata image. Now let's go to our preview function and click here build and refresh to see. Directly here we have rendered here an image, and we have other properties which we have to pass here. So for example, here we can pass in here the content scale. So let's pass in here the content scale. And this is just when we want to customize our scales. So for example, we can just call here our content scale.crop. So if the image is going to be bigger than the view which we are going to have, so sometimes we want to crop the image perfectly and not stretch it. So basically here we can just call here content scale.crop, or when you press Ctrl S, you can see there are different types of properties which you can pass inside here. You can pass, for example, inside fill with fit and other things which you can just use to pass them. So this content scale is whenever you have an image that is going to be displayed, for example, inside a card, and this image is quite big than the probably view, then you are just going to pass inside here this thing here. Okay, so another property is here which you can try to change. Let's try to change the alpha. So the alpha represents the opacity of the image. Now, for example, for a case, let's just give it 0.5f. So you can see that we are going to decrease our opacity to 50%. Let's preview again and see. You can see here the image decreased its opacity to 50%. So these are some of the properties which you can use to pass inside here. Now, for example, when we want to try to round out the corners of this image here, we can use a modifier to do these things. So for example here, let's just remove this opacity. I think it's just making our picture worse. So for this case, let's pass in here the modifier. And for example, we want to create rounded corners. So we can just pass inside here the modifier, and we want to clip this. And here basically we can pass in a shape that is going to help us to round the corners. So now we can just pass inside here, for example, rounded corner shape, and give it a size. So we want to, how much do we want to round the corners? So we have to pass in here, for example, 30%, or you can just give it 30 dp, for example. And basically, if you know XML, to round the corner of this particular image is going to be a really hassle. So you have to create custom XML files or drawables, and then you have just to clip them. And that is going to be a really tough thing to do just for rounding the corners. Now let's look here at the magic of composables. You can see our composable now, the edges are rounded by just adding these 2 lines of code here, the clip and also rounded corner. And now we clip our rounded corner image here. Now you can add other special properties like the transform modifiers. So we have a transform modifier if we want to transform our image. So let's call here a rotate. So there are several of these. So let's just call here a rotate modifier. And then we want to rotate this to a certain degree. Now we want to rotate this to a 5F. So 45F, this is just going to be 45 degrees in terms of this, but we are using here a float for this case. Let's preview again and see our image. Okay, so now here you can see our image is rotated 45 degrees. And one thing you can be asking yourself, now we are not getting here our rounded corners. And why this is happening here is because, for example, our image is outside here. And another case here which I want to highlight to you is that modifiers are executed sequentially. So for example, here we have called first the clip, then we call rotate. So first this composable is going to call this clip, and then it's going to call the rotate, because composables are called sequentially. Okay, now we have seen here our image and also our text here. Now we can try to rename this. Let's control Shift F6. In order to rename this particular function, let's call this Hakuna Matata text. Now, the next case here which I want to create is I want to combine between the text and also the image here. Now, we can create here a new composable preview function, or we can just create here a new composable. Let's create here a new composable. And now the great part of composable functions is that they are reusable. So we can just reuse them across different composables. Now let's just call this Hakuna Matata content. As here, now we can call our Hakuna Matata image. For example, let's call first our text. And then you can just call here your name. So I'm just going to call Hoodlab. Then we can just call here our image. But let's just keep this first. So we're just calling here our Hakuna Matata image and also Hakuna Matata text. And let's create here a preview composable for this case. So you can create many preview composables as you have your composables. And here basically now, let's add also this and call this Hakuna Matata content. Now let's call here our Hakuna Matata content. And let's re-preview here and see. Okay, so here we have our content. As you can see, we have the image and also we have the text. But one thing you can see that they are overlapping together. So we have the image and also we have the text. And this is just because we don't have any layout. So Compose framework is going to render everything on top of each other. So for example, if we call again another text here, let's just copy this. Let's Ctrl C here for our text and pass it here. Now instead of name, let's just pass in here. Let's just call this Lion King. You can see here our texts are completely on top of each other and we cannot read. And this is happening because we don't have any layout that we tell, hey, we want this text to be arranged, for example, in a top to bottom format, or we want to arrange them from right to left or left to right. So we have to tell the composable, hey, now we want to arrange this in a certain format. And how can we do that? And basically that is called layout. So if you have been using XML, then you know that we have relative layout, we have constraint layout. Also, we have, for example, something like linear layout and other things which you can use to arrange your content. So in Jetpack Compose, basically we have three major composables that we can use to arrange our content. Okay, now let's just remove this. Several types of composables layouts that we can use to arrange our content. So we have a column, we have a row, and a box, which these three you can use to build even the Play Store application. So there are three major composables which you can understand. So when we used XML, we were told that we have to use a flat composable structure, a flat view structure. So we had to use a constraint layout, but this is not the case for composables because it can efficiently handle deep nested layouts. So for this case, we are going to be using majorly these three. So there are more which you can just experiment at your own time, but these are just the core concepts which you can use them. So for example, here, let's press Ctrl X and create a new column composable. Now, as you guessed here, a column composable is just going to arrange this in a vertical sequence format from top to bottom. Otherwise, we have to specify a reversed column. So for this case, inside here, our column, we can now call directly our data and pass in here our image and the Hakuna Matata text. Now let's try to re-preview again, and you can see the difference as we had in our previous image. Okay, now you can see here the text actually is just arranged at the bottom now. You can see we have our first image because we arranged it from top to bottom. So the image is going to be rendered first, then we are going to have the text rendered again. And you can see here the difference between this and this, because here with this text we applied here a padding modifier, and inside our image we did not apply any type of padding. Now let's just remove this padding first here so that we can have everything look evenly. Okay, so we have removed that padding. Another thing here which we can do is apply modifier inside here. So we said that a modifier is just a special property that is going to be available on different types of composables, and this modifier sometimes can have different properties than the modifier which you find it from the text. As you can see here, now we have our modifier for our column, and for this case we have the modifier inside the column scope, and when we used it inside here we can just get different properties. Now, one thing which we have here, the layout modifier, we can try it, for example, to fill the max size. So basically now our column is going to take up the whole space which is going to find inside our screen. And now we can just use to align it to different types of places. So for example, inside here, a column, we have a property for vertical alignment. So we can pass in here the alignment and how we want to align it. So you can just call here arrangement. This is called the vertical arrangement. Now we can just call arrangement dot, and basically now you can see we can arrange it to the bottom, center, top, space around, or space between, and space evenly. So for example, we want to arrange it to the center, and also we can use the horizontal alignment inside here, and we want, for example, to align it also to the center. So we can just call, let's just call this alignment. Let's just give it alignment.end. Okay, now let's re-preview here and see the changes which we have. Now let's go to the design directly. So you can see here we have told this composable to take the max size. So it has taken the max size, and you can see we have arranged this to the center and to the end. And when we want to change this, for example, and go directly inside our composable here, now let's try to, we want also to arrange this to the center here. So we can just call directly here .center, and this is going to align this particular composable to the center. Now let's try to build and refresh again. Sorry, we have here a problem. So what we can do is call this center horizontally and not center, because these have different scopes. So you have to call alignment.center horizontally, because we cannot arrange this column to the center. So as you can see here, now we cannot make these serial errors when passing something that is not going to be useful to a particular property. Basically, Android Studio is going to give us the error here. Now let's try to rebuild again and see. And you can see this is going to shift from here and then going to the center. Okay, so as you can see here, now our text is aligned to the center of the composable. So we have taken the whole mass size and we wanted to make this text to be a center, and now we can just arrange it directly here. So the next composable that we can change here is the row composable. So I think you have already guessed what the row is going to do. So the row composable is going to be similar to the column, but with the difference that is going to arrange this in a horizontal sequenced format and starting from left to right. Otherwise, we have to specify it to start from right to left. So for this case, you can see now we are just getting here these errors because now the row has different properties than the column. So here, for example, we can change to be horizontal alignment, horizontal arrangement. And you can see now we can arrange this to the center. And here now we can change this to a vertical alignment. And now we have an error here because these are not going to be applying here. So let's just call here our alignment. And now center vertically and not center horizontally. So you can see the difference here. Let's just go inside here and re-preview again and see the differences. Okay, so you can see now we have our image arranged horizontally together with this one here. So I think the image here is quite big, so I want to reduce its size here. For our case, we can just go to our Hakuna Matata image, and here we have our modifier, and before we apply the clip, we want to change the size. Now let's change here the size. It's just the modifier, and we can just give it, for example, let's give it 56 dp. Okay, so you can see here now we have our image decreased its size. But right now you can see now whenever we apply this, we have a rounded corner because right now we have 56 dp and inside here we have a rounded corner of 30 dp, which is quite large. So if you want to have the same effect here, you can just decrease this here, or you can just use a percentage. For example, you can just use a 20%. That is going to be different than the dp which we used previously. And quite now you can see whenever we change with percent here, now this is going to look perfectly here. Okay, so one thing you can see here, this text here is quite added inside the middle here, and also they are just compact here, no space that is given. So for this case, we can just add a padding modifier to this case. So for example, to differentiate between this and this, we can add here a spacer modifier or a spacer composable, or you can just add a modifier and then add a padding to a particular item. And most often you can see people using a spacer. So a spacer is just a special composable that does not render anything than a space. So basically here we can just pass in a modifier and give it a size, for example. So this we want to give it a size, for example, of 20 dp. That is going to create a space or of a size of 20 dp, and it is going to differentiate between our text and also the image because we have added here the image, then we have our text. Now we are going to add that particular spacer inside here. Let's try to rerun again. One last one is just a box composable. So this one is just a quite special one. Let's pass in here a box composable, and we're going to get errors here because the box composable does not take any of these. We can easily just pass in here the modifier, and the next case here is to pass in the content alignment. So this is just similar to what we are going to have before. Now let's try to rerun here and see. Okay, so you can see now the image and the text are laid together, and the box composable is expected to work like that. So it's going to render everything on top of each other. We have our image, then this image is going to be rendered at the background, then we have here this one to be rendered at the foreground, and then we are going to have this Hakuna Matata text rendered at the top of these layers here. So for this case, this is just similar to what we had before, but right now we have a control of this. So for example here, we can just pass in here the content alignment, this to be a different one. So inside here, we can pass in the content alignment, and now we can just align them to the center, or we can just align them to the bottom end. And now we can just use composables directly here to change this particular, for example, direction. And one thing which I did not mention here is just it's best practice to pass in an empty modifier as a parameter so that you can just use the scope here, because the modifier are actually scoped in a certain scope. So here we have, for example, a box scope. So there are modifiers that are just available inside the box scope, which you cannot find inside the raw scope. So for this case, when you want to apply this to this particular text here, you can just pass in here your modifier. So for example, let's pass in here our modifier and give it a default modifier. This is just what I refer when I say an empty modifier. It's just we have here a default modifier that if we don't want to pass in a modifier, then we can just leave it as it is. And instead of that, then we can just pass in here our modifier, for example, and pass in the modifier again. Now, when we navigate back here, we have the ability now inside our box scope, change the modifier. And now let's give it the align item here. So we want to align this to the end. So for this case, we can just call here alignment.end. Okay, so we pass in here alignment.bottom-end. And now let's just look at here and see. So with content alignment center, we aligned here our image to the center. And also you can see here we used our text and align it to the bottom end. So this is how you can easily use these box modifiers. And these are just really powerful, and we can see whenever we progress through this crash course. Okay, so we have seen how we can use a row, a column, and a box. And basically we can nest them together to create something useful in our UI. So for example, here we have this text displayed inside our box. So we can try to use here, for example, a row in order to arrange it perfectly as how we want. So for example, let's just press Ctrl X here and refactor this with a row. And here basically we can pass in our text. And instead here we can also pass the vertical and horizontal alignment. Now we can pass in here arrangement.center. And also let's pass in here the vertical alignment. And we can call here alignment.center vertically. Another thing, we want to fill the max width for this case. So let's pass in here a modifier. And fill the max, not max size. So we want to fill the max width. So this is just as simple as that. We have refactored our text. And another thing you can see here, we're getting an error because this align here modifier is not inside our row scope. So for this case, we have to change this, and this is only available inside our box scope. So here, instead, we had to use another thing. So you can use this align modifier, but not with the same parameters. So this is the great thing with Jetpack Compose. Basically, you cannot get weird outputs. Okay, so the next case also here, we can change this. So instead of fill max width here, we can just give it fill. So we want to fill the max width. Now the next case here is to give it a padding. So we can just give it a padding. And we want to give it a padding of 16 dp. To arrange everything, then we can change the background color of this particular box here. So let's change here the background, and we can pass in here the color. And it's just easy. We have, for example, let's use here a blue. And we want to decrease the opacity of this blue to give it a slightly something like a tertiary color. So for this case, we can change the alpha by calling here .copy. Then we can just call here our alpha value and give it 0.5f. Or let's give it a 0.4f to make it more vivid. So for this case, our text is going to change here. Now let's try to preview and see the changes we have made. Okay, so now you can see here our new preview. We have here our image, and also we have our text. And the background color here has changed because we have a box and we have changed its color here. So I think also here we can just remove this red color here because it's just for demonstration purposes. It is looking weird. Okay, the next case here, we can change this opacity here. Let's just give it a 0.2f. Make it more into a white color. Okay, so now it's something better, and you can see here the image is touching here these edges of the box. So for this case, we can just easily fix this by going directly to this image here. And here we had given it a size of 56 dp. Now we can just give it a little bit of padding. So after we clip here, we can just give a padding. And we want to give it a padding for the top. So for this case, you can just give it a vertical padding. You can pass in here different types of parameters. So for our case, we are just going to pass in here a top padding, and let's just give it 8 dp as the padding. Okay, so we have here a padding that is given, but you can see here now the rounded corner are just going away. And this is because we are applying the clip first, then we are applying the padding. So we have to apply the padding, then the clip the last. And this is just the thing which you have to get really cautious, because modifiers are applied sequentially. So you should understand first, okay, so I have to pass this one first. So we have to give it a padding, then we have to clip it to this shape so that we can have that rounded corners. Otherwise, else we are just going to get an output that is not desired. You can see we have here our clip to that shape, and also we have the padding applied between these two text here. So now I think everything is looking perfectly. Well, the best thing about Compose, we can use Kotlin features directly on these functions. So for example, if we have a list and we want to render items according to the list, we can use a loop directly to get the desired output. So for example here, if we had a list, let's collapse this. And for now, let's just go directly here inside our set content. Okay, now let's remove this. Let's create here a column. And inside here now we want to use a for each loop. So for example, let's create here a for loop, and we can use here I in 1 to 10. Okay, so we have here a range from 1 to 10, and we want to call here our Hakuna Matata content. And now we have here our content. Let's try to run and see. Now you see here we have a list of 10 items, and basically we can't scroll. We can easily fix this by adding here a scroll modifier to add this behavior to our column. Okay, so we can use here Kotlin features, and it's not just the for loop. We can use any type of Kotlin feature directly to these composables. So I want to highlight here one thing. So when we have, for example, 10,000 items on our app, we'll have a performance hit and probably crash due to memory usage. So you can see here we have only 10 items, and we can render them because a column is going to render all of the items available. So if we have, for example, thousands of items, it's going to try to render all of the items, even those which are not visible, which is just a problem. So using this approach is inefficiently, and luckily with Jetpack Compose, we have a solution for the issue, which is going to be similar to a recycler view. So I want to demonstrate to you when we are going to have this error. So for example here, let's have 1,000 items to render here. You can see, or let's just give it a 10,000. You can see that our application is going to have some issues to load, and probably by time if you have small resources, then your application is going to crash. Okay, so our app is launched and nothing is showing here because the column is going to try to render everything here, and basically we are going to have some issues. Okay, now you can see our application is closing because it cannot keep up. We have here a memory exception, and this is not good for our application. So how can we fix this issue? So to fix this issue, we should use two special composables, and these composables are called lazy column and lazy row, which are two powerful layout components in Jetpack Compose designed to efficiently handle large lists of items. So they are specifically optimized to load and display items as they come into view and not load them at once, which helps improve performance and memory usage. So we also have lazy list composables, which are, for example, the lazy grid, lazy staggered vertical grids, and other things which you can use to optimize your views. So for our case, we are going to stick up with the column here because we have our items displayed inside the column. Let's see how we can implement a lazy column. And it's going to apply to almost all other lazy composables. Now let's delete this here, and let's create here a lazy column. So it's just really easy. If you're coming from XML, you know that creating a recycler view is going to be a hassle. You have to first create, for example, the adapters, then you have to hook up the views, and also you have to create up the layout for that case. And this is just going to be a hassle for creating a lazy column or a list that scrolls. And for this case, in Jetpack Compose is just really easy. It's one composable away from getting up a list. So for example, here we can use items as we did before. And now we are going to use here the count. So you can see we have here different types of overloads which we can pass in. So for our case, we are just going to use a count. Now let's give it the same 10,000 count here, which is just the items which we have, and it's going to be similar to what we used a for loop for our case. Now let's just call here our Hakuna Matata content. Let's look at the difference which we are going to get here. Now let's try to run again. Now our app is launched successfully and we don't have any issues. Now you can see we are just scrolling even though we passed also the tens items here. So we have 10,000 items here which we are scrolling through. And this is just the power of Jetpack Compose. With just simple clicks here or simple lines of code, we have been able to implement a scrollable list, which when using XML is going to be a really hassle to keep just something like this one here. So that is it when you want to display lazy items. You can use a lazy column, and this lazy column is going to display items in a vertical sequenced format that is scrollable and also efficient. So if you want also to display items that scroll horizontally, basically you can use a lazy row. And if you want to display them in a grid, so for example, you can use here a lazy vertical grid, or you can use a lazy horizontal grid, or you can just change here the staggered grid and other things, which you can experiment at your own time. Okay, so we have here our items displayed, and we have been hard coding this data directly. So our applications usually are interactive. So a user is going to click a button, a user is going to type and add items, and basically this is requiring us to interact with our application. But currently we are not interacting with our application. So in Jetpack Compose, the UI is immutable by default. Basically, whenever it's rendered, then we cannot change the UI. So when the UI is rendered, it cannot change. So how can we change the UI if it's immutable? So we have to understand here a really important concept, which is just the concept of a state. So if you are familiar with React or Flutter, then this is going to be a bliss. You can be asking yourself, so what is a state? So a state basically is just any value that can change over time. And this is very broad definition. So anything that can change can be a state. But with Jetpack Compose, this must be observable and reactive, meaning that the composable framework has the ability to track the changes and update the UI accordingly. So we can demonstrate this in our code. Okay, so now let's demonstrate here and see how we can use a state inside our composables. So you have to pay attention to this topic because it's going to be really crucial to understand so that you can create your application. So with the XML, the state was handled internally. And sometimes you are going to have a really hard time whenever you want to implement something customizable. So you'll have to override items and create your own items from scratch. So you had to override like 3 to 5 files so that you can have a simple thing. But with Jetpack Compose, the state is decoupled from the view. So the UI is immutable. So to change the UI, you have to change the state for this case. Now let's create here a new composable. And we are going to call this a task item. Okay, so inside here, we want to track our state of a task. For example, we are going to be adding a task here. And for this case, we can create a variable. And we have said that a state is anything that can change over time. Now let's just call this task. Then, for example, here we can initialize this by var and change it to an empty string. And basically, whenever we change here, we can change this task here. But this is not reactive, and this also is not going to be observing by composables. So composable is going to think, hey, this is just a variable, so let me just skip it, and it's going, whenever it's going to be invoked, then it's going to be initialized back to this. Also, there is one important thing which I want also to highlight here. We have something that is called a recomposition. So recomposition is just a mechanism in which whenever something changes, then the composable is going to be recalled so that it can change the UI, because we have said the UI is immutable. So recomposition is just calling back the composable to reflect the updated changes. So for this case, whenever we initialize here variables for the first time without a proper tracking mechanism, then this variable is going to be lost whenever we perform a recomposition. And it's just basically something whenever we recall it a composable here. So for example here, if our task is going to be equal to this, and then we initialize this task, for example, I'm just demonstrating here, to, for example, 1, 2, 3. So whenever we call here our composable, then the recomposition is going to change this back to this one here, and then again going to change to this one. So this is going to be called multiple times here whenever the recomposition is going to be recalled. And for this case, we are going to have weird output. So we have to keep a mechanism of tracking our composables. And the next case here is with composable, we have a special thing that we can use to track our state. And that is called, for example, a mutable state of. And this is just a mechanism of tracking our state. And basically when you press Ctrl Q, you can see returns a mutable state initialized with the past values. So the mutable state class is a single value holder whose reads and write are observed by composables. So basically this, whenever this is going to change here, we are going to observe our values. Right now here you can see, let's pass in here an empty value as our placeholder. But here we still get a problem. You can see here creating a state object during composition without using remember. So there is something here which I want to highlight you. We said that we have a recomposition, meaning that whenever something changes, then this composable is going to be called here in order to render a new UI. So for this case here, we have a problem. Whenever we call this, this is not going to be observable by composable. So we have to use a remember in order to keep track of this. So we have, for example, a state from 0, then we increment, for example, to 5. Now we want to keep this state across recomposition. So for this case, we have to use a remember. And basically we can easily do this by, let's press Ctrl X and wrap this inside a remember function here. You can see we have this composable, and basically now we can pass in here a mutable state, and now the error is going to go away. And for now, we can just keep track of this variable. So if the user types something, then we have a recomposition, then we are not going to have any problem inside our text or inside our composable. Another thing here, you can see we are getting back when you press Ctrl Q, you can see this is just going to be a mutable state. Now directly here we have to call .values. So let me demonstrate this. So here, for example, we have a text field. So a text field is just a composable that is going to be like an edit text inside our traditional views. So here we have to pass in two things. So you have to pass in the value, which is just the task. So for example, here we have to call the task.value. And also, whenever the user types, we have to track the things which they use to type. So for this case, we have to override, or we have to pass in here the property that is called the onValue change. And this is just a lambda function. So you have to understand the lambda in order to use this by ease. So this is just a lambda function. And here we have our task, and we want to reinitialize our value. So we can call .value. And this basically onValue change is going to return us with a string. So when you come here and press Ctrl Q, you can see that the callback, we have this callback here onValue change that takes up a string and returns a unit. So for this case, whenever user is going to be typing, we're going to receive here a string. And in that case, we have to update our state here in order to reflect the changes. So here we have a highlight, and this is just for material experimental APIs. Let's just add in here a material experimental API. So right now here we have our text field, and also we have our state. So this is just the state, and here we use the state to display the values. And here also we have the onValue change that is going to help us to change the state here. Now let's preview this and see the changes which we have. Okay, now let's copy this and let's just call this preview. And directly here, let's just call our task item. Let's go to our preview and see. So here is our preview, and we have nothing here. Now, one thing which you can do inside here is you can see these buttons here. So if you want to preview animations and if you want to start an interactive mode. So for our case, let's click here to start an interactive mode. And now we are inside interactive mode. Now we can just click here. You can see we have a cursor now. Now let's just type inside here. You can see our text is typing. And if you don't do this, basically you are going to have an empty text field that is not going to be updating. So you have to manage your state rather than just keeping the thing there. Okay, so another thing which I want to add here is a button. So whenever we click that button, we want to display a list, or for our case, for now, we are just going to show a toast message. So for this case, let's create here a button. And now we have to use here a layout composable in order to show up this inside a column. So we can create here a column and we have here our text field. And basically below here, we want to display also a button. And here on the button, we have the on click. This is just going to be invoked whenever we click it. And the next case here, we have to pass in here, we have this place where we can provide, for example, we can pass in here a text or an icon or anything else which you want to be shown inside your button. For our case, we are just going to create here a text. And for the text here, we can just call this add. And this one is going to add up our item. So for this case, inside here, our on click, whenever the button is going to be clicked, we want to show a toast message. And basically we can easily do this by just calling here our toast. Okay, so we have to pass inside here a context. So with Jetpack Compose, you can easily get the context by calling here local context. And the text here which we want to show is the task. That is going to be our context which we want to show here. Okay, so we are having here a problem because this context here cannot be called outside of the composables. So you can see inside here the on click, we have here the callback functions, which is not the composable. So for this case, we have to track this outside here and call this context. Now let's pass in here the local context, because we are just accessing this inside the composable scope or composable function. Now let's pass in here our context. Okay, so we are getting here an error. This error is arising because here we have to use a task, and this task here is not basically a value directly. So here we had a problem by calling here .value and here .value. So we can easily access this by using a by keyword here. And by keyword, this is just an extension function that is going to help us to avoid calling .values every time whenever we want it. And you have to import this if you see here we have an errors, you have to place Alt insert. Now let's remove these values here. And also here, let's change the .values and directly change here our task. Now you can see the error is going to go away because here we use directly this by keyword. So if you use an equal sign here, you're going to get a state value that you have also to use .value in order to access its item. Okay, now here we have our composable, and basically now we have here our text. Let's see this inside our preview. Okay, so here we have our preview. Let's go inside the interactive mode here. And now let's just type here random items. So I don't know if it's going to show here the context, the toast, but you can see we don't get this toast here until we run this inside our application. Okay, so for this case, let's just go back to our main activity. So here we had our lazy column. We have to just delete this. And basically, whenever you want to use your to show this inside a phone or inside an emulator, you have to pass in the composable inside here, the set content. Now for this case, let's try to rerun here and see. Okay, so here we have our app launched. Now let's try to type inside here anything. Let's click add here. You can see now we are getting here a toast of this text which we have added here. So everything is working as expected. Now the next case here, I want to disable this button here if this text field is empty. And basically, to track this, if this text field is going to be empty, we have to look at this task here. Because we have initialized this to an empty string, basically we can easily check this inside here. So inside our button, let's just keep this in a separate line. Now we have here a property that is called enabled, and we can pass in here a boolean value to understand if this is enabled or not. And basically we can just pass in here our task and call it .isEmpty, or if it's not empty. So basically if this is going to be empty, then it's going to return true, and if this is not going to be empty, then it's going to return false. Now let's try to rerun and see. Okay, so here you can see we have our button grayed, and this is not enabled, so we cannot click this button here. Now let's try to change here, and you can see now the button is changing because here we have added the text. And this is just the great thing about composables. So if you use XML, probably you will know that to implement something like this, you'll have to write, for example, 9 to 10 lines of codes here in order to achieve this. And right now here we have our button enabled and disabled. Now let's try to delete everything. You can see now the button is disabled because we are just tracking the state here, and composable is intelligent enough to know now, okay, the task is empty or is not empty, and basically enable and disable our item. Okay, so we don't want just to show here a post whenever we want to display our data. So we want to display this inside a list. So for this case, we have to create a separate composable. Okay, now let's create here another composable. One thing which I want to highlight here is that we have here our state about the task. And basically we have here our items that are going to be added to this task here. Now we have a button that is going to add this task. But how can we display this task inside the list? So here we can probably create another state. So for example, here let's create a state and call this task list. And for now we can use also our remember, and instead here we used a mutable state. And instead of using just a mutable state, we can use a mutable state list. So let's just call this mutable state list of. And basically now we have a mutable state list of. And by default here, we are going to have an empty string. So here you can have a list of items that you probably pass. For our case, we are using just a string. Now we have this task list here. And whenever we click, we don't want just to show here a toast. What we want to do is to pass in here the task items. So we can just call here our task list and call .add. And this one is going to add the element. And what element do we want to add is the task which we have here. And you can see right now we have our items which are going to be inside the list. But the problems which we have here, this task list is inside this composable here. And we want to display our task items inside the task list items here. So we have two separate composables, but the state is inside this task item list here. And we want to use inside the task item list here. So we have a problem. How can we have this state basically displayed here? Okay, so what is state hoisting? So state hoisting is an important concept in Jetpack Compose, which allows you to manage and share the state of your user interfaces efficiently. So in Compose, each composable function should ideally be a pure function that takes in input and returns output based on that input, so without managing its own state. So state hoisting involves moving the management of the state to a higher level composable. So often this is just the parent composable, which then passes the state down as a parameter to its child composable functions. So this is going to have a lot of benefit. As you can see here, we have a problem that now this state here is required to be used in this state here. So we can reuse the state whenever if we make this state moved outside to the set content here. And also it's a clear separations of concern. So this task item here is going to be responsible just to display the UI, and the management of a state is decoupled from this function here. So let's see how we can perform state hoisting. And this basically is highlighted with Jetpack Compose, that is called unidirectional data flow. So we have the data flowing from the composable caller, and for our case here, the composable caller is this set content here. And for this case, we want also to display our state inside the task item list. So we can move this state from here to here. And basically this task item here is going to receive the inputs, and we can use the callbacks to send back the changes which we have here to this composable caller here. And the unidirectional data flow is basically that the state is going to be inside the set content, and this is going to flow downward here. So the state is going to flow downward, and then we have the events that flow upward to the set content composable caller here. So how can we do this? Basically, now we can create here, for example, a task parameter that is just going to be called of type of string. Now we should also have something that is called an event. Basically, an event is just an action that is going to occur. So for our case, we have here an event for these changes here. So you can see when you press Ctrl Q, we have the on value change. So for our case, we can just name this on task change. And similarly, this is going to take up a string and return us a unit. So we have here the first things which we can just remove this state here. Press Ctrl X. And now we can just pass this to this composable caller here and pass in here our text, our task. And for this case, now we have our task. Now we cannot change the task here directly because this is immutable by default. What we can try to do here is call the on task change directly, because this has the same properties here. We can just call it directly here as a reference. And now everything is going to work similar. The next case here, we are performing the addition of the items here. And we have this also, we want to move it to the composable caller. So here what we are doing, we are hoisting our state. So removing this state here to the composable caller. And now here we have an error. So we have the task list items. Also, we have to add another event because this button doesn't need any type of a state, but it emits an event. So for this case, we have, for example, we can call here on task item add or on add. Call this on add task item. And this is going to return us with the unit. So you can see here, now we can add an item. And basically here we can pass inside here a string directly. Now here we cannot pass in here the reference directly because we have here the on task. So what we can do, we can just call here on task, on add task item and invoke this function here. And now we have to pass in here a string. So we can just call here the task that is going to be passed directly here. And for this case, we can just go upward here, or we can just omit directly this string here in order to invoke it directly, because we have this state hoisted to the composable caller. So no need to pass inside here a string and then use that there. So now here we have something. We have here the task item, which let's press Ctrl P. We have to pass inside here the task. So we can just call here our task. Now we can pass inside here the task item. The next case here is on task change. So similarly here on the task change, we can just call here our task, which is going to be equal to it, because this is going to be passing up a string. As you can see here, our task change is going to have a string parameter that is going to be sent with it. Now the last case here is we have the on add task. And probably you have seen that we are using here a trailing lambda syntax. And this basically means that whenever we have here a callback or a lambda function as the last parameter, we can probably use this syntax here. So don't get confused whenever you see this type of syntax here. But I probably prefer to use the names directly so that I don't confuse them. So I know now this here is responsible for changing and this is responsible for adding. So for this case, let's put these parameters on a separate line. Now we have here our task item. Now we can call our task list and call .add. Now directly here we can just show our task item. And we solve the problem by state hoisting. So this is really crucial whenever you build an application to hoist your state. You can hoist your state to the view model, and basically now you can start to reuse it across composables. Now we have here our task items and everything is looking perfectly. The next case here is what we want to also display here is the task item list. And here probably we're going to have error because here now we are required to pass in here the task item. So for our case, for task, let's pass here an empty. Then let's just pass in here empty lambda composables. Okay, so this is just for preview purposes. We have implemented here. Now the next case here, let's implement this task list items here. And basically for our case, we are going to use here a lazy column. And this lazy column here is going to receive up the content. Okay, so we can receive here our items as a list of a string. Now we can display these items and directly call here our items and open up here. Now here we have the lazy item scope, and basically now here we can display any type of composable. So inside the items, we can display here, for example, a text. And here you can see we have a reference to it. That is just a string. You can rename this reference here. So let's just call this task. And now we can just directly display here the task. Now let's give a little bit of a spacer. Let's give it a space of 16 dp to differentiate between these two items. Okay, so here we have our task list, and directly let's go inside here our set content. Okay, so we have here our task item. Let's display them inside a column. So we can press Ctrl X here and create a column composable. Now here we have our task item. Now we can differentiate between these two composables, the task item, which is responsible for adding our item and displaying the list. So here let's add a divider, and here we can pass in here the modifier. We can just directly leave this as the divider here. Okay, now let's call here our task list, and we're required to pass in here the list, and because the state we have it here, now we can just call this task list. So you can see now we can reuse our composables here directly because of state hoisting. So this is going to promote that with a cause reusability. Okay, now let's try to run our application and see. Now our app is launched. Let's open up here our text field. Let's pass in here task 1. Let's click add here. You can see now the task 1 is also displayed. Let's change this to task 2 and click add here. You can see also we are adding here, and also task 3 and more. We can just keep adding this. So now we have here a scrollable list. Okay, so you can see here now we have this composable that is going to be reused this state inside another composables. So I think we have learned a lot through this crash course. So if you find value out of this video, please don't forget to provide a like and subscribe for more videos like this one. So we hope you have found this crash course on Jetpack Compose insightful and helpful in getting started with modern Android app development. But remember, this is just the tip of the iceberg. If you are eager to dive deeper into the world of Jetpack Compose and Android, don't forget to explore more content on our channel. We have a treasure trove of tutorials, tips, and in-depth guides waiting for you. And for those of you who are hungry for even more knowledge and wish to become Compose and Kotlin pros, we have got a comprehensive course with over 20 hours of content that will take your skills to the next level. It's a fantastic opportunity to become an expert on these cutting-edge technologies and building amazing Android app. So what are you waiting for? Subscribe, explore, and keep learning. The journey in the world of Jetpack Compose and Android development is an exciting one, and we're here to guide you on every step of the way. Thank you for joining us, and we look forward to having you as part of our growing community of learners. Thanks, and bye-bye for now. See you in the next video.